Okay, let's start our next hour, okay, and this week. And we introduce hierarchical clustering next hour, right? So let's take a look how do we perform hierarchical clustering by using Orange, okay? And of course you need the data, okay? And most of the time, the data provided by Orange are suitable for classification problem or regression problem. So they do have target, but it's okay. We can still use the data, okay, to perform hierarchical clustering, okay? So that's okay. We use average data, okay? Still, we have 4 different features and we have 150 data points. So that's right here. So for hierarchical clustering, okay, as we mentioned before, it is an unsupervised learning, right? So you have to see right here. Here, we have a tab, okay, that lists several different hierarchical clustering. We'll mention some of them later, okay? So very first things, okay, if you need to take a look at this data, okay, use a data table right here. And for the unsupervised learning, it's right here, right here. Okay, as we mentioned before, okay, the distance is the key to perform clustering. So take a look at this one, okay, this delta, that is distance. So we drag a distance widget right here, okay. Let's take a look. Just double click it and we can see that right here. Wait a moment, okay, right here. Okay, as you can see that the distance function, okay, they have several different settings can be set here. The first one is distance between, okay, usually because our data has different rows. For each row represents a data point, right? So we select rows right here. So the distance we'll have to compare is one row compared with another row, and so on and so forth, okay? So that is rows. Next is the distance matrix. Okay, so there are several different distance functions. Okay, the first one is Euclidean distance, which I present to you. Okay, if we have 2 data points in the surface or 2 data points in the space, okay, we abstract them dimensionally. Okay, make a square and summation and make a root square of it. Okay, that is just a very simple definition of Euclidean distance 尤拉距离，不管是2维、3维、4维都是一样哈，就是在那个轴上相减，然后我们去算那个欧几平方平方和开根号的那个距离都是一样。OK， The second one, as I mentioned, Manhattan distance 曼哈顿距离就是在不同的维度上就是相减绝对值，然后就直接算和了，直接算和了哈。So there are several different distance right here. Okay, I will for example this one cosine. Cosine distance. Okay, if I have 2 vectors in a space, how close they are. Okay, we can calculate the degree 就是角度 between these 2 vectors, right? And we can do projection 就是投影的长度，这个我们算跟我们之前算那个 SVM 很类似哈。We can calculate the projection length by using cosine distance function, so that we can evaluate the distance between 2 vectors in the space. So that is cosine distance. Okay. We will talk about Jacob distance later. Okay. There are several other distance right here. Okay. Usually, if we would like to evaluate numeric data, I think Euclidean distance is okay. Okay, so we simply just use equivalent distance. Okay, so we connect our data to this distance widget. So this distance widget will create a distance matrix for us. So we don't have to calculate it by ourselves. We just simply do such kind of connection. Okay, and after that, we like to do hierarchical clustering, right? It's right here, like a tree. So drag it right here, and we start it right here. Do you see that? The hierarchical clustering region, its input is distance. So we simply just connect the distance to the hierarchical clustering. And we're done. The algorithm used by this distance matrix and used by this hierarchical clustering widget is exactly the same as we told you in the last hour, which is UPGMA. Okay, so we simply just how do we observe the result? Okay, click. Simply just click. Let's see. Just double click it. Okay, then we can see that. Okay, at left hand side, okay, at left hand side, you can see that single, average, weighted, combined. There are several different parameters can be used in hierarchical clustering. If we simply just click average, it means UPGMA. When we say UPGMA, the A means average, mean, M means mean. So if you select average right here, it's exactly the same what I told you in the last hour. Okay? So at the right hand side, you can see that, okay, here is 150 data points, and it is the connection of those data points is decided by the distance matrix. Okay? So the closest one will be will be combined as a group. Okay, and right here, okay, since those data points are connected all the way to the root, right? Something right here. Okay, and here is a line right here. Okay, you can drag it. Okay, for example, you can drag it here, right here. You can set your own threshold to see how to partition this tree. Okay, if you can set it lower, for example right here, so that we can have a cluster right here, cluster C2, cluster C3, cluster C5, and so on and so forth. Okay, you have to for such kind of clustering algorithm, you have to decide where you make this cut. Okay, where you make this cut. Okay, there are several different annotation right here. Okay, usually they are just you don't have, because you don't have target. Okay, usually you can simply just use enumerate. Means, okay, data point number 9 will be combined with data point 14 and 39 right here. Okay, however, for this iris data set, okay, we have target, right? So we can simply just select target, which is iris right here. So we have to show, okay, in this cluster C2, all of the data set, okay, now they are not all. They are all setosa in this small cluster. Okay, for C3, most of them are setosa as well, right? Setosa as well, because the features in the 4-dimension space, they are closed, so we cluster them into one cluster, right? So they are clustered C2, C3, C4, and so on and so forth. Of course, some clusters are not that clean. For example, C12. Okay, some of them are Virginica, some of them are versicolor right here. Okay, but among this cluster, okay, only one data point belongs to versicolor. Rest of them are Virginica. That means one of the data point, which is a flower, right? Which is a flower. Its feature, it has 4 features, right? Its features is close to this cluster, so we class them based on the features, okay? So on and so forth. Because such kind of family tree, we call it family tree or family tree. Such kind of family tree is very easy to understand and very easy to explain. So sometimes we use such kind of algorithm to analyze unsupervised data. Okay, you can simply just move the threshold. Okay, to have different clusters. Okay, or you can manually select. Okay, I would like to have 3 or 4, 5, 6 or 10 clusters and manually decide. Okay, that is that is hierarchical clustering. It is very nice to have such kind of algorithm. Okay, you can analyze them. Okay, so let's go back to the next clustering algorithm. Okay, which I believe is very useful. This one. Okay. If you go to our list, okay, our schedule, okay, after UPGMA we have k-means right here. Okay, it is a code which is on the GitHub. You can open my GitHub by using your code lab. Okay, that is totally okay. So here is it. Okay, that is k-means. K-means is another way to help us to analyze unsupervised data. Still, okay, we would like to do clustering. Okay, depend on the distance. Okay, but unlike UPGMA, unlike hierarchical clustering, okay, it has different approaches. So let's take a look at this code. Okay, so k-mean is a very simple partition clustering method. Okay, so take a look at this data. Okay, this one. Okay, I randomly generate this data point. Okay, in a 2D surface. Okay, the way I create randomly, okay, not that random, okay, create this data point, okay, I use 3 central E 就是中心点的意思 okay, which is marked as the black circles right here. Okay, I have 3 central E and I randomly generate data point around this central E with different variance. 就是我先随机选了3个中心点，然后在这三个中心点的周围随机的生成一些点，然后给予不同的 variance， 就是variance 值啊，所以它会在那中心点附近有大有小，会有一些这些数值。Okay, so for such kind of data point, okay, if I don't know this data point is generated from 3 central E's with several different variances. Okay, if I simply just take a look at this data point, and I would like to cluster those data points. How can I do? Okay, so here is how k-mean does. Okay, first, at first place, the people who try to analyze data have to decide a number. This number means how many clusters you would like to k-means to help you to cluster those data. At the first place, you may say, okay, I would like to cluster those data into 5 different partitions. And how did you decide these 5? We will teach you later. But at the first place, you have to tell the algorithm how many partitions you would like to apply on this data points. Okay, so for this example, I just simply select a random number 7. So I would like to use the k-means to help me to cluster all those data points into 7 different partitions. Okay, that is this example. Okay, and the first step is, okay, look at the figure, to randomly, okay, to randomly plot 7 different data points on the original space. 好，所以它的第一步是，既然我要分7个区域嘛，对不对？我就随便的在里面找7个点，就是这个红色的几个，应该7个，对，7个，就随便找，真的是随便哦，完全随机的 ，OK，totally random，OK，you select 7 data point， OK， and I mark them as in red， OK， that's the first step， OK， the second step, take a look at this one, the second step. Okay, that's the first step. Okay, we have several group points. I randomly select 7 of them and mark them as in red. Okay, that's the second. That is the very first thing. Okay, the second step is that, okay, since we know how to calculate distance, so that among all the other bullet points, I calculate the distance between each bullet point to all the other red points. 好，中文再讲一遍哈。我有了7个红色点跟其他所有剩下蓝色点之后呢，我要算什么？我要算每一个蓝色的点到这7个红色点的距离。这很简单嘛。Okay, the first step, select 7 random points, calculate the distance of bullet point to all the 7 red points. And of course, select the smallest one. For example, I have a target point right here. So I calculate the distance between this bullet point to all red points, right? And select the smallest one, which is this one, should be the smallest one, the colorless red point. And I mark this bullet point by using this red point. Okay, since we have 7 different red point, okay, so I select 7 different colors right here. So that is, see right here, okay, the yellow one right here, okay. I have 7 different colors, so I have 7 different partitions right here. The bullet points now are marked as the color which has the smallest distance with the red point with the yellow color. So this red point has the smallest distance among these yellow points. 好，就是说呢，我们对每一个蓝色点去计算最小的红色的距离嘛。那一定会有最小的嘛，那我们就选定那一个。那我们对那个点呢，就是随机给个颜色吧。好，那比如说以左下角这边，我们选了黄色。好，那我们就把所有跟这一个点恰好是最近距离的那些人呢，全部都标上黄色。好，所以左下角现在就会自成一区。这一区的人里面是什么呢？这一区黄色的点点的人的 data point， 他们距离这个中心的这个红色我们刚刚随机选的那个红色点是有最小距离的，好吗？他们跟其他的点的距离都没有这个红色的小，所以他们就会被暂时在这一轮就会被标记成这个黄色，比如说黄色以这个例子来说就是黄色。And of course, we do all the same things to all these 7 regions. So it means at the right button part, right here. All those light green points has smallest distance to this specific red point. So we mark them all in green. The color is just a random color, okay? For example, it's just a green color. So by doing so, we can simply just partition the original blue point by using a 7 random red points. Using the distance, okay, using the small distance to make sure which partition it belongs to for all those blue points. And of course, we mark them in different colors. Okay, that's the first round. What about the second round? The second round means, okay, the second one, I use another color, okay? I use blue one, okay? The second round, how do we do? After we do doing so, what is the second round? The second round is we simply just remove this central E in each partition, and then in this partition, for example, the light green one partition. For example, there might be 40 data points, 40 light green data point in this section, in this partition, right? So we select, okay, the real central E by using for all those light green data point, we select a new central E. The new central E has a specific feature, which is it should be the center of all these data points. Okay, it should be the center of all data points. How do we find this point? It's quite easy, right? For example, that is x1, that is x2. How do we find this blue point? It's quite easy. For all these light green points, we simply just average their x1 and x2. We can find the new data point, which will be the new central E of this light green partition. 好，下一个步骤是说，那我们在我们用那个红色的点找到了一群青绿色的点之后，我们就不管那个红色的点了。我们在所有的青绿色点中找一个新的 central E， 就是中心点。这中心点怎么找呢？看啊，这是个2维的平面嘛，对不对？是不是有 x 跟 x1 跟 x2？ 就把这些青绿色点所有的 x1 加起来做平均，就会得到 x1 的就是得到 x1 轴上的中心点嘛。然后把青绿色点所有的 x2 加起来做平均，就会找到一个 x2 的中心青绿色的 x2 的那一轴的中心点，就这样，没有什么特别的，就是找新的 central E。Okay, so for the second round, we find a new central E of the light green section, green section, dark green section, dark purple section, and yellow section, and this section. So at the second round, we can find, we just ignore all the red points. We only look at the color points. For each section, for each partition, we calculate the new central E for each partition. So we have 7 new central E, right? Those central E might be or might not be the same as the red point, which is okay. But now, at the second round, we find a new central E. So we can see that is the second round. So that The new central E also marked as red, the new red, okay, the new red data point. Those central E is more makes sense because they truly at the center of each partition. 这个新得到的是 central E， 我们还是把它码成红色的哈，然后我们就把它画在图上。这个新的 central 会比较 make sense 一点。因为它们真的就是那个新的那个真的就是那个颜色的中心点。大家要知道哈，在上面那个我们那个不一定会在颜色的中心，它只是很靠近，就是那些颜色只是很靠近原本的红点而已。可是在下面这个新的红点呢，它们是真正这个有颜色这一群人的中心点。这样我们就完成了第二 round。Okay, that is the end of the second round. We have new central E, which is more makes sense. They are not randomly selected by some random number. Okay, and what next? If you download my code and run it in your Jupyter notebook, it is an animation. Okay, it is an animation if you can execute it correctly. After that, we use for the third round, we use the new central E to do the repeat things. What is that? Use the new central E to mark the closest node. 就是在下一个阶段呢，我们会用这个新的 central E 再重复动作。那重复什么动作呢？去重新的再标记一次颜色。As you can see that when we find a new central E such as right here. For example, that is a new central E, right? That is a new central E. And take a look at this pink point. This point. This point was the member of the right of the green. This pink point was the member of the light green partition, right? But after we have a new central E right here and here, the next round, this pink point will belong to the left central E because it is more close to the left hand side. So we will use the new central E to do new partition again. 好吗？你可以看到这上面，因为我们现在移动的 central E 嘛，对不对？所以大家的相对距离其实就稍微换了一下。所以某一些在边界的点啊，原本是属于旧的某一个 central E 的，可能因为新的 central E 现在比较靠近它了，所以它就会在下一轮被划到新的 central E 的那一边去。And so on and so forth. So the execution step is like that. In the first round, it is very different. Okay, we randomly select some central E, and then we partition the rest of the data point by using the random select central E. And then in each partition, we select a new central E. And then we have new central E, right? We do the new partition. And then we find the new central E. And then we do the new partition. New central E, new partition, new central E, new partition, and so on and so forth. And after a few rounds, we believe the central E will not change much. Will be stable somewhere in this space. Okay, so and then all the blue points will be partitioned, depending on how many central E you select at the first place. 就是在最后啊，我们就是不断的重复这个动作嘛，哈，选一个 central E， 然后把剩下的点做 partition。partition 完之后呢，不要管 central E 了，在 partition 之内找一个真正的中心点，当做新的 central E， 然后再不要管 partition 了，在新的 central E 里面再做一次 partition， 然后在 partition 之后呢，就不要管 central E 了，再找一个新的 central E， 然后找到新的 central E 就是不要管 partition 了，我们再做一次新的 partition。周而复始之后呢，其实这个 central E 最后会稳定下来，我们相信它会稳定下来。 然后你就可以停了。然后在最后的那一轮的最后的那个 centroid 啊，还有那个最后的那个 partition， 就是所谓的 cluster。At the last run, the last centroid and the last partition is exactly the cluster you are looking for. We are looking for. Okay, so finally, for example, if we have an iris data set, okay, we partition it into 3 clusters by using k-means. Okay, this average is called k-means, and we'll partition like this. Okay, but the next question is, since this algorithm requests the analyst, which we should provide how many clusters we should cluster, right? But when you take a look at this data set, if it has no colors, usually human beings will say, okay, I partition it into 2 clusters, not 3, not 4, 2, because obviously it can be partitioned into 2 data sets. But however, for some data set like this, how many partition you should choose? 2, 3, 4, 5, 6, 7, 8. Basically, you don't know. So sometimes we will just do it like something like this, called elbow. Elbow 就是手肘的意思 ，elbow plot 就是手肘的这个图。What does that mean? That means I don't know how many clusters I should partition. So basically, if I have a data set, then I ask k-means to do 1 partition, 2 partition, 3, 4, 5, 6, 7, 8, 9, 10 until whatever you want. So we simply just brute force， 就是我们暴力的去让它分1群、2群、3群、4群、5群、6群，就是随便你到几群你想要的。就是因为我们不知道要分几群嘛 ，because we don't know how many partitions we should partition this data set, so we just ask the k-means to partition it into 1 cluster, 2 cluster, 3, 4, 5, 6, 7, 8 cluster. And for cluster, okay, we have for cluster, we have a very interesting things. Okay, 1, data in cluster. Okay, in cluster should be similar. What is similar means? It means has less variance or less standard deviation. 就是我们在做这个 cluster 的时候，有一个很基本的概念，就是我们为什么会认为它是一群？是因为它们都缩在一起嘛，对不对？所以在群内要记住，我们现在用的词汇叫做群内，叫 within cluster， 或是叫 with， 就在 in cluster 哈。他们这样相似，所以他们应该要挤在一起。他们挤在一起的时候，表示他们的标准差很小，在那个空间里面，对吧？So that is rule number 1. The data within the class should be similar, which means they are crowded. 他们就是很拥挤。Okay, they has less variance or less standard deviation. Okay. Rule number 2. Data between cluster. Between 的话，中文我们可以翻译成群间哈，就是每一群之间哈 ，should not be similar 嘛。 the data between the clusters, they should be somewhere which far away. So they should not be similar. They are not crowded. So they should have high standard deviation. 就是群间的东西啊，因为他们看起来一群一群嘛，他们中间一定有空隙嘛，对不对？所以他们看起来比较遥远一点。那看起来比较遥远一点，表示这一群跟那一群的 standard deviation 比较大一点，就是他们的标准差要大一点。啊，如果他们在，比如说你放在一个二维平面的话，就是 x 轴跟 y 轴嘛，他们 x 轴的 standard deviation、y 轴的 standard deviation 要大，所以群内要看起来挤嘛，群间要看起来散，这样才叫做一群一群嘛。 对不对？这个是一个很简单的概念，就是人的认知嘛。So take a look at this view graph. What does it say? Average within the cluster sum of square. Average 就平均嘛。Within cluster 就是指上面这个 ，this one. OK. Sum of square 标准差怎么算？标准差不就是减掉平均值，然后 和的平方什么鬼的之类嘛，对不对？所以左边的这个意思呢，它其实就是代表的是标准差的意思啊，只是它写的怪怪的，但是没有关系。So we have index, which is standard deviation, to help us to say, okay, I have a data set. If I cluster them using k-means into one cluster, or two clusters, or 3 clusters, or 4, 5, 6, 7, 8. The standard deviation between clusters should decrease when there are more and more clusters, right? 对吗？你看嘛，你假设有一团资料，然后你就分一群，啊，那个群一定里面松松散散的嘛，对不对？那个群里面就没标准差异就超大嘛，对不对？好，那你分两群，就硬随便一个资料，你硬把它分两群好了。那你硬把它分两群之后，你会发现，比如左群跟右群好了，左半群跟右半群，他们可能看起来很松散啊，对不对？那他们之间的标准差就还是蛮大的嘛。当你的群越分越小的时候，你会发现啊，他们之间呢，好像群的效果看起来越来越跑出来，对不对？ 那平均而言，群跟群之间的距离是不是就会变小？标准差也会变小，好吧？这个稍微用想象的，好不好？这个很难画出来，用想象的。但是你要知道，你有100笔资料，你可以硬把它分成100群。那你把它硬分成100群之后呢，就是每个点之间的平均的距离哦，其实也蛮，就是理论上来说会蛮小的，对。所以实际上它是一个 向下的曲线会越来越小，越来越小。但是我们通常会我们为什么把这个叫做 elbow 呢？就是因为下面这个曲线的图长得像那个手肘嘛，是有个弯折的点嘛，哈。那我们通常会怎么选择说到底要分3群还是4群？我们通常会在你觉得有转折的那个地方，就觉得说啊，有转折的地方表示说前面的群看起来都分得不好。 到了这个点之后，开始急转直下，变成说，哎，好像看起来的确群的效果有出现，那只是越后面分呢，群的效果就看起来没有分得这么好了。比如说像下面嘛，像下面就是分2群看起来不错嘛，啊3群看起来也还好，可是你要硬把它分成4群的话，效果好像就没这么好了，对不对？但是实际上那个标准差还是会下降的，那个距离还是会下降的。 但是看起来效果没这么好，所以它就没有像前面 dramatic 的往下降这么多，就是那个标准差。所以通常我们会选一个转折点的地方来选择我们的 k 值，这个 k 值就是 k mean 的 k， 就是群，我们要分几群。所以下面这个我们可能会分2群或3群。那上面那个就那两个讲哈。So take a look at this elbow plot. Okay, that means what is the deviation or distance between different clusters? If you cluster the data point into 2, partition 3 or 4 or 5, usually we select the turning point, which is right here. Like for example, that's 3. Of course, 4 is okay or 2 is okay. It depends on you. Okay, so basically we select the turning point, which is 3, which means k equals 3. That means we partition the data point into 3 different partitions, which is K3, so that you can easily use this to partition data. Okay, let's take a look at orange as well. Okay, if you would like to do k-means, that you don't have to calculate all these partition things and centrality things. You simply just right here. That's k-means, right? That's k-means. Right. So take a look at the input. Okay, the input is data. The input is not distance, right? It's right data. So simply just connect the data from here to here. So this widget will help you to calculate the partitions and the centrality. So double click it. Okay, let's take a look right here. Right here. Okay, there are several. Of course, since it is k-means, you have to set a number, the value of k. But if you don't know how many clusters, you can see, you can simply just click it. Okay, let's say from 2 to 8. 2 to 8 means, okay, I don't know how to set the k. So please, okay, k equals to 2, 3, 4, 6, 5, 7, 8. Okay, but in orange we don't have the elbow plot. Okay, it has another index. Okay, you can simply, but the theory is the same. Okay, you see where you can find the curve turns. Okay, you have to look at turn it 90 degrees. Okay， 就是看这个表，它不是会往下降，你就看哪里感觉有一个转折点，你就选那个值。那这里可能要不就3，要不就4嘛，因为那个你画一条线在这里，转折点在这里。So or you can assign it. For example, I want to partition those data by using 3. Okay, and then it's done. But how did you know which point is partitioned to which part? Okay, you can connect a table right here and simply click connect it right here, and it will say, okay, that is the white columns are original features, right? And the gray colors are the target. And here we have an additional 2 columns, okay? And here is the cluster. C2 means cluster number 2, C3 cluster number 3, C1 cluster number 1, something like that. 就是它会直接告诉你答案啊，因为它没有办法把那个过程跑给你看嘛。So of course we can plot all the things. For example, here's a visualize, right? We have scatter right here, and we connect the data to the scatter plot. Okay, we connect all the data to data right here, and we can double click it. And we can see that right here. Okay. We have 2 axes. Okay. Petal width, sepal length. So we can cluster it this way. And the color right here. The color right here is the Y. Okay. The iris is right. Of course, you can select cluster right here. The cluster right here is C1, C2, C3 made by k-means. So take a look at this view graph. Okay, the left bottom side, those data are originally labeled as blue color, which is Sentosa. The middle part, okay, is original label as Versi color. Right hand side is Virginia. That is the original data. Okay, and after we select the cluster right here, that is the cluster made by k-means. The left-hand side part is quite good, but the right-hand side part, that is not as good as the label. So k-means has its limit because it only uses the distance to partition the data. Okay, after that, that is good. For example, we can, here's the color. Okay, we can use shape. Okay, as you can see, the color is the cluster, right? That is made by K-means. The shape is the original label, okay? Come with the data. So as you can see that there are 3 different colors, right? And the data marked as X is versicolor, okay? So X right here is versicolor. However, some of them are not in green. This green is class number 3. So some of the color right here at the right hand side, they are labeled as triangle, which should be virginical. 你反正这个工具很好用嘛，你就可以根据颜色或者 shape 来调嘛，就可以看到其实它们有不一致的地方。就是按理来说，最棒应该就是像左下角这样，红的全部是圈，绿的应该全部要是叉。可是你看到绿的有些不是叉，因为在 K-means 的角度里面，他觉得这个跟这个比较近，所以它应该要是三角形。可是实际上在 label 里面，这个是这个 label， 表示 K-means 在这个工作上没有做得很好，没做得很好。Okay, let's 2 different unsupervised learning. One is K-means, the other is hierarchical clustering. And just take a look at those view graph. Okay, you can. Oh, here, that is the 7 partition made by K-means on the data which. Sorry. This one, okay? That is the at the end of the slide, okay? That is the K-mean cluster. 这个要下去。这个就是我们刚不是随便弄了一些资料点嘛，对不对？那你硬要把它分成7群，或者是8群，那它就会长这样。它会在那个平面上画出一些区块，然后跟你讲说地点在哪里。这个 Python 都可以做到，或者你用 Orange 做也可以做到，只是 Orange 就没有办法画那么漂亮。Orange 是直接告诉你这些就 mark C1 C2 这样子。Okay. So that is 2 of the unsupervised learning clustering algorithms. UPGMA, which is a hierarchical clustering, and K-means, which is they take few steps to figure out how to partition data in the space. Okay, we have homework this week, so you will receive an email which tell you how to write your homework, how to handle your homework online. So make sure you check the email today or tomorrow. Okay, that's it.